1 2 1 2. How's it going, people? Now if you're watching this back after the stream has already finished, then by all means feel free to jump forward a little bit. If you're here to see the Bassface modifications, then we're going to be looking at a ground zero first, just quickly while the stream picks up. So if you're interested in seeing this ground zero, oh, this camera does not seem to be working just now. That's unusual. That one's usually fine. This ground zero that got on the bench here is GZCA. It's like one of the full bridge pieces of rubbish thing with a faulty inductor. So we're just going to go ahead and look at that. If you want to look at the Bassface stuff, then feel free to skip forward a little bit. Yeah, you'll be able to see that soon. How's it going, everyone? Good evening. Welcome to tonight's stream. It is a Friday night. What are you saying? Friday night things. It's a Friday night. What's going on, guys? Hope you're well. We've got a couple of bits on the stream this evening. Now, there's a potential for 3 different main events this evening. The first thing I'm just going to be quickly sorting out is this ground zero GZCA, which I've got on the bench with me right here. This is one of the cheap piece of rubbish Chinese full bridge things that ground zero are charging absolute extortionate money for compared to what they should really be worth. How's it going, Mr. Richmond? Good to see you here, my friend. Been a while. Hope you're doing all right. This one has no dead fetch or anything, but it appears to have a dead output inductor. These are not seated down well from factory. Look at the state of this. Ever seen one of the DD mono amps go pop? Yeah, loads of times, man. The DD amplifiers are nothing special or magic. They fail just as much as any other amp, really. I'll WhatsApp you. Oh, cool. No worries. I won't be able to look at that till after the stream, though, probably. CJ, what's going on, bro? I'm good, thank you very much. Have you still got a couple of M21Ks that need looking at? Get them up to me, bro. So, for everyone that's just joined, like I said, I'm just going to be quickly looking at this ground zero first while the stream picks up a little bit, and then perhaps in half hour, 45 minutes time, depending on how long this takes, and we'll crack on with the Bassface that you're all here for. I know, it's all good. But we can have a look at this ground zero, see what these are all about. Looks like a little clone of the Taramps HD series. Yeah. This is kind of the same as the audio pipe that I was doing the modification on ages ago. It's slightly different, actually. This one's only got one. The audio pipe only had one transformer. This one's got 2. This is supposed to make 3,000 watts, actually. So this is more like a sound digital clone. This isn't a Taramps clone. This is more of a sound digital clone. What sounds you say is the most reliable and well-built amp? So for high power bass application, the best stuff that I'm seeing at the moment on the market is the Powerus amplifier stuff. I would generally say the 1 ohm versions are the kind of best all-rounders. I would stay away from the 10K though. The Powerus 10K seems to be not quite up to what the rest of them are for some reason, but the Powerus PW5K, 8K, 15K, they're pretty awesome. The 1 ohm version and the 2 ohm versions are really cool. I wouldn't really recommend the 0.5 versions. Yo, Adrian, thanks for the 10, bro. Appreciate you, my friend. That's very kind of you, dude. Got any wine sip on for the stream? So this stream, I'm working on some customer some customer repairs. So I'm not sipping on anything too extravagant this evening because that would be a little bit irresponsible. Sometimes I'll have a glass of Ribena, if you know what I mean, with some repairs that I'm doing, if they're like for a good friend or it's not, it's not too serious or anything. But if it's something proper business, proper client related, then yeah, I'll just keep it nice and tidy with some agua mineral. The Ashy one has arrived. Bro, what's going on, my friend? What's going on, my friend? Smash the like. Yeah, appreciate it, man. Thank you very much for the support. Love, big love always. Now, how does this thing come out? We're missing it. Ah, yes, there's one screw that I've missed. Yalon, what's going on, my friend? Yeah, I've got two that need to come up, bro. I'm needing to have a chat at some point with you and Donnell to see if we can make 1.5 happy. Those amps you can get away with running at 0.5. So basically, there's no modifications I can really do to them to make them like, to make them any more current happy. You know, they're using the biggest, baddest output MOSFETs that exist. They're already using the biggest, baddest power supply MOSFETs that exist. They are already as beefy built as they can be for their board. So I can't make it any more stable at lower impedances than they already are. But if you want to, now this is a little trick that some of you guys might not have thought about. Okay, so we're just going to take you over to the cheeky watts calculator right now. Now this is something interesting. Now CJ, pay attention to this because this is going to be relevant to you. So I'm just going to go to rapid tables real quick. I'm going to go to the watts ohms amps volts calculator. All right, so that amplifier M21K that makes 10,000 watts RMS into 1 ohm. Okay, so that means that across the board, across the PCB, okay, there will be 100 amps worth of current across the output section. Now, we adjust for efficiency a little bit. Obviously, at 1 ohm, these might be like, I don't know, 75, 78% efficient. So you expect to see more than that across the power supply section, okay? But the ratios will be the same when we change it in a minute. So let's just take this for a number. This nice easy numbers: 1, 100, 1, 10,000. So for 10,000 watts RMS into 1 ohm, you've got 100 amps worth of current across the output section. Okay, now let's say that you want to wire this amplifier down to 0.5, but you don't want this amp to be under any more stress than it is at 1 ohm. So you want to make sure that this amp is as reliable as it is at 1 ohm and not get any hotter than it is at 1 ohm, but you need to wire it to 0.5 just because of your setup characteristics. You know how stuff's wired. You only have a 0.5 ohm node. You can't wire to 1 ohm, so 0.5 is all you've got. But so what we want to do is we want no more than 100 amps across the output section, because that's what we have at 1 ohm. So if we ask for any more current across the output section than we had at 1 ohm, then things might start failing and things might get hotter than they should. So we're going to stick with 100 amps, but we're into 0.5 this time. Now, we saw here a minute ago that in order to get 100 amps across the output section of that amplifier, we needed 100 volts. And the voltage reading here is volts AC at the speaker terminals. So at the speaker terminals, at 1 ohm, you'll have 100 volts, which will equate to 10,000 watts RMS into a 1 ohm load. Now with a 0.5 ohm load, obviously, with 100 amps across the output section, the voltage is going to be less. So we calculate. As you can see here, with a 0.5 ohm load and 100 amps across the output section, basically you're limiting the amplifier to 5,000 watts. And 50 volts across the speaker terminals. So if you want to play super safe, okay, and if you want to make sure that at all costs there's no more current across the output section than there was with the amplifier making 10k, then you have to limit this amplifier to 5,000 watts RMS and allow no more than 50 volts on the speaker terminals, and that will play all day long for years and years, as happy as it would have been at 1 ohm. At 0.5, just at the 5,000 watts there, because you've got 100 amps across the output section, like you did with 1 ohm. So now naturally you'll have impedance rise, so you could go a little bit more than that. You could say, okay, well, let's assume that I'm rising from 0.5 to 0.78 at the max, the lowest impedance rise, which is usually box tuning frequency, okay? And let's go 100 amps across the output section again. So now you're limiting the amplifier here to 78 volts across the speaker terminals. So if you can, calculate your rise, but generally, if you want to be absolutely 1,000,000% safe, then you limit this to 50 volts AC across the speaker terminals. But if a real world safe point to be in is probably somewhere between the 1 ohm voltage output and the 0.5 voltage output. So in this case, probably somewhere around a 75, 78, 80 volts AC across the speaker terminals maximum would be fine with this amplifier at 0.5, accounting for some box rise. So yeah, that's probably what I would suggest to you. If you want to wire this at 0.5, don't ask for the full 100 volts AC out of the terminals, because then you're risking there being too much current across the output section. Just stick to somewhere nearer to 50 volts AC in this example, but you can go a little bit more if you feel like it can provide a little bit more with the impedance rise. What's going on? Yo. So, okay, this should be coming out of the case now. This is just a little ground zero we're starting with, just to whet the appetite, if you know what I mean, for this evening. So, the ground zero GZCA. This is a Chinese sound digital clone piece of rubbish that they charge way too much for, in my opinion, because you can get these like stupid cheap from other brands that don't charge the world for this clone circuit. All right, now we need to pull the inductor out. So let's get this cooked up. Let's get this heated, and let's remove the output inductor, because this, I believe, is shorting because it's wobbly as heck. The output section, we don't have any dead MOSFETs, but when we try and power it up, it just draws excessive current. We do get Class D switching, but it just draws crazy amounts of current when the Class D switching initializes, which suggests that there's a problem with the filter network, which will be the inductor here. So I'll have to get a DATS on it when I can. Yeah, DATS would help for sure. Obviously, the only problem is that DATS is only applying a very low signal. The impedance rise will change as the woofers get to their high excursion. So it's not super reliable, but it'll give you a rough idea, perhaps. So yeah, have a look at that if you can. I've got the van wired to 0.5 at the moment, as was at us having them mounted in flat wall, but they're pre-wired out of vibes. Okay, I'm not sure what you mean by that. Transformer at 2 ohm per sub. So I was going to have them at 1 ohm per amp and strap the amps, but not sure what the 21K is like to be strapped. Dude, they're full bridge already. You can't strap them. Okay, you can't strap a full bridge amp. It's already fully strapped internally. So all you can do is just gain match. Yeah, you can't strap a full bridge amp. So just gain match. You can have coil A on one. All of coil A on 1 amp and all of coil B on the 2nd amp. So you can wire every single subwoofer's coil A. So let's say you've got like, I don't know, 2, 3, 4 subs. Wire all of their A coils on 1 amp, and then all of the subs B coils, I'm calling them A and B for, you know, the 2 dual voice coils, wire all the B coils on the 2nd amp. And what that allows for is, it means that if there are any slight deviances between the amplifiers in their gain position, gain setting, or the low pass, or anything, if the amplifiers output slightly different power at any point, what it means is that it means that still all of the subs are still going to be getting the same power, because one of their coils is going to be getting the power from one of the amps, and the other coil is going to be getting the power from the other amp. So therefore, all subs still receive the same amount of power. Whereas if you wire 1 sub per amp, or like, you know, a couple of subs per amp, then you risk, if there's any power differences, some of the subs getting more power than the others and getting unloading and problems that way. So that's why I always recommend doing it like that. How's it going straight up? What's it going on, bro? So, inductor, let's get this bad boy out of here. I should really have turned on the big soldering iron for this, but it wasn't heated up and it takes a little while to get going, so I just thought I'd try just with the small AOUA iron. I might need to turn the temperature up a little bit. I'm on 350. See, let's go up to 400. That should be a bit better for getting this out nice and quick. Definitely want to preheat the board for this, but my heat gun, I'm currently using my heat gun hooked up to a mains wire. I'm using it as a current limiter for when I work on mains amplifiers. Talking about mains amplifiers, I'm shortly going to be working on a, what is it even called? Labgruppen 14K, something like that. I've got a couple of those potentially. I've got one already here, and then one of them potentially might be coming to me. Those are pretty big amplifiers, I believe, so that could be good fun. But yes, in the stream this evening, just quickly while the stream picks up, we're going to be looking at this ground zero that I've got on the bench right here, just sorting out the output inductor that's got a short, I believe. And then we're going to be looking at the Bassface 5K modifications. And then if there's time, And then if there's time, I did get, oh yeah, look at that. I did get the parts through for the T amp. So yeah, there's your problem, buddy. Our output inductor is toasted. No, is that salvageable? I think it is, because that's just on the end winds here, isn't it? Look at this. So if we just unwind these a little bit here, I might be able to just like tester tape this. Basically, this amplifier is not worth doing a super long complicated repair on, because it's so cheap for the manufacturer. So this is like I think this is a warranty repair, this one, so it's not worth doing like a really long ass repair job on and rewinding this whole thing. But obviously we've got some delaminated wire here, and we've also got some here, so I'm just going to need to like isolate that by hopefully unwinding it far enough and then running some electrical tape around the delaminated ones and then just winding it back up again. I think that's going to be the quickest and easiest and best solution in this instance, just so that this amplifier isn't written off at least. This won't be any problems. It's not going to cause any loss of performance or anything. Just means that it can be repaired and put back out on the streets. Give me the hat cam, might be better for that. There we go. All right, so I've exposed all of the wire that has burnt off its lamination, its coating. So let's just get that out, wind that around one more time, and then start isolating that. There we go. Okay, sick. Right, so we've got a little section here to isolate. Now I can either use tester tape or I can use electrical tape. Tester tape's nice to work with, but it's a bit thicker, and the problem is when it's thicker is this won't necessarily rewind as tightly as it did from factory, which can be a pain in getting the number of turns correctly. So we're just going to use some electrical tape, and that should do the trick. This is some brand new electrical tape, courtesy of SimeWave02. Thank you very much, my man, for dropping this down with some other bits that you sent over. Very much appreciate that. I've got a DD1 that I use for setting the in phases in the van. Don't use a DD1. So honestly, is no need to use a DD1. No need to use a DD1. The times where DD1s are required have far gone. That's not the best way. You're far better off setting them using, if you need to set your gains to like a certain voltage, obviously use your multimeter. If you need to set your gains to clip point, then I almost guarantee your amplifier is going to have a clip light built in anyway. If not, then if it's a class D, then you can hear the clipping from the buzzing sound that the amplifier board makes, so you can set your gain that way. Or to be honest, you can just hear it from the subs. Like you can hear, if you're by the sub, if you put your face, your face relatively near to the cone of the sub, you can hear it. You can hear when you reach clip point. Or if you really can't hear it, then you can just use my little trick that I documented years ago with the little inline capacitor and a small speaker or tweeter, which will buzz when you hit clip point. Don't buy the DD1. Waste of money. Pain in the ass to use, overly complicated, causes people to not set their gains anywhere near as high as they should be. Yeah, not a fan. Not the fan of the DD1. All right, so that's that part of the laminate wire sorted. So now let's do this second bit down here that was all cooked up as well. This is really nice electrical tape actually, SimeWave. Cheers for that, appreciate it. Has the live chat died? Oh no, it hasn't. There was just nobody chatting. How's it going, my man? Giannis, how's it going, bro? I made a clip detector, said Ashi. It cost me $6 from Parts Express. Works like a charm. Sweet. Is that the little trick with the inline film capacitor and the little speaker that I documented years ago? because yeah, that works really well. It's it tells you when clipping happens earlier than the DD1 will, and earlier than you can really read on an oscilloscope as well. Yeah, nice. I'm really glad to see people making use of that little tidbit that I shared years ago. It's really cool to see. All right, let's wind this back up. So hopefully I can get this as tight as it was before. Let's go around here. I didn't count the turns, but to be honest, I don't really think it's going to matter too much. Because this isn't got many turns on it, and it's a tiny little thing. If we're a bit short, we can always extend it a little bit with some extra wire. It's not the end of the world. Will this PVC tape not melt again when getting hot? Well, the idea is the inductor shouldn't get that hot. Like, if the inductor's getting that hot, then there's something wrong. So, no, this shouldn't really melt. This PVC tape will isolate the shorts, which is what we're using it for, well within the operational temperature of this inductor. This inductor may hit up to, like, I don't know, 60, 70 degrees Celsius, 80 degrees Celsius maybe. It's only a little amplifier. It's not mega going to get super mega hot. The reason that this has got cooked is because of vibration damage, and not because it overheated. So I mean, it overheated because of vibration damage. It didn't overheat like because of it overheating because of operational reasons. So it should be absolutely fine. Okay, there we go. What I will do is, now that that's wound back up, I'm going to check the inductance of both of these to confirm that they are suitably within spec. You can see here, yeah, look, I don't know if you can see, let me just zoom in on this one. You can see here that this is the sort of thing that causes it. Wait for this to focus. Maybe I need to zoom out a little bit. Okay, so you see just here, you get these rubs, and this rubs on the main PCB and on other legs and stuff. So provided we isolate that and don't let that touch anything, then this will be absolutely fine. What am I drinking today? Just some water, bro. Just some fresh agua mineral. Got to stay hydrated and all that, you know. A couple of reasons I'm not having a Ribena is working on client repairs, and also I might need to drive later as well. So, all right. Well, there's our inductors. So let's check the inductance of these on the ESR meter. And it's going to be this one. So first one, which is the first wind. Let's turn the multimeter on to get continuity between them. Okay, there we go. There we go. Make sure there's no continuity between winds. That's good. There's not. So let's drop that over the meter. See what that's reading, this one. That goes on there, and that goes. Oh, it turned off. Nice. All right, so we have, if I can get this to stay locked in. This is kind of awkward, not going to lie. Right, get that there, get that there. Okay, we have It's going to jump around a little bit. This tester isn't the most accurate thing, but I just want to make sure that they both behave the same. So we've got 0.1 millihenry there as one of the numbers that it kind of settles on. Okay, now let's check this other one just here as well. This is the one that was untouched. So what's this fluctuating between? 428 nanohenries. Oh, here we go. 0.1 millihenry. When you see the nanohenries, it's just because it can't read properly. So there we go, 0.1 millihenry. So yeah, that is reading the same. They're both reading the same now. So let's go ahead and drop this back in the board and just see whether both of these channels, if you like, of this full bridge amplifier both behave the same. And Mr. Vlog style videos, we do more of those. So those kind of vlog type of videos, they don't do well at all. Nobody wants to watch those, apart from maybe you and like 10 other people. So there's no point in me making those videos for my main channel because it will just kill my channel in the algorithm. So I have made a new channel, it's actually an old channel that I've renamed, called Bearvid's Clips. So on that channel, I may consider putting out some more kind of long form, just vloggy type videos of what I'm doing with my daily life with the Proton and what's going on with the van and stuff like that. But I don't want to make that kind of content on my main Bearvid channel because it's just going to absolutely kill the channel with like getting like 200 views and then just like settling off. So if you're interested in that type of content, obviously it doesn't make me any money doing like videos that get like 200 views, so I'll only do it when I've got time. But if you're interested in that kind of content, I'm thinking about just whacking up a couple of videos of updates of, you know, the Proton and the van and stuff like that. Go ahead and subscribe to Bearvid's Clips. And I'm also putting some funny or notable parts of my live streams on there as well, for quick viewing and people that didn't necessarily want to watch the whole live stream, but they just maybe want some information about what we spoke about. So you could also use some cloth tape on top of the electrical tape to make more heat resistance. Yeah, not a bad idea. I could put some tester tape over the top of that. The only thing I don't want to do is I don't want to put the tester tape on the laminate while that needs to be wound, because it's very thick, so then you can never turn it. You can never like get it turned enough to work, get enough turns on it. Okay, so that is all sucked out from the board there. Yes, as you can see, that got pretty spicy down in here. Very spicy. Hot, hot, hot. All right. So we've got one inductor here and one inductor here. So let's just confirm that I'm putting this back in the right way. So we should have low side drain on this one. And then this one should be this one. Yeah, okay, perfect. So we want it to go in something like, got that one there and that one there. So it doesn't really matter where they go, as long as like, yeah, because it doesn't really matter as long as these are isolated from each other. That's all that matters. So we just don't want to put like both of those in there. So one of those and one of those in there is fine, and then one of those and one of those in there is fine. Cool, yeah, that works. All right, so let's shove. Let's get rid of the solder blob on the end of here. And then shove that one in there to start as an anchor point for us to bend it around with. I'm a sub of that channel now, thanks. Great stuff. If anyone else wants to subscribe to Bearvid's Clips, then by all means, feel free. Like I say, there'll be some other random content on there and little clips from the live streams of interesting bits and bobs, so worth giving a subscribe to, I'd say. Alright, so that's the first lead anchored in. And now let's work our way to getting these other ones in as well. So this one here, I need to shove that right down there and get that in the hole that's kind of covered with glue. So let's try and get that out the way. Get the glue out of the way, because this stuff just goes conductive in years anyway, so that can just get out of the way. Pull that off. Get some pliers. Okay. Oh, just out of interest, has anyone been to see the live action of Snow White yet? Be interested to hear your thoughts. It's not like a mega blockbuster film or anything like that, but Snow White was a Disney classic. Just curious to hear your thoughts on the live action that they've made. Shove that in there. There we go. Very nice. Looking good. Yo, what's up, Matt? What's up, Daniel, as well, my friend? You are very successful. Hello from Turkey. What's up, my friend? Thanks for jumping on. Appreciate you jumping in from all the way from Turkey. It's cool to see. I'd rather go blind than watch that iteration of Snow White. No worries. Well, tell me your reasons. I'd love to hear like people's thoughts and opinions on like live action remakes of the old Disney classics. I'll tell you one I haven't seen actually. I haven't seen the live action remake of Mulan. I really enjoyed Mulan as a kid. That was one of my favourites. So I haven't wanted to have it ruined because I know that they changed the storyline a fair bit, and that's always kind of annoying when they do that. I had to walk away from Disney. Too much trouble from that corporation. It sounds like you're working with them though, bro. Like, a film's a film. You can still enjoy a film. All right, last one. And then if this is happy, we shall seat it down nice and strongly with some adhesive or something. Some kind of silicone will do the job. There we go, that's in there nicely. So fortunately there's a nice amount of flux in my solder wire here. See this? This is flux core solder wire, so luckily that prevents me from needing to add some extra additional external flux, which is very expensive. My Chip Quick stuff cost me a bloody fortune, so I only use that where needed, and the flux in this this wire does more than good enough of a job. There we go. Right, let's just check that that works before I add loads of glue and stuff. Because it's too woke. Alright. Is that because of how they've changed the story, or is that the choice of actors and actresses? What makes you call it woke, out of interest? Do you use lead solder? Yeah, absolutely. I will not use lead-free solder for what I do in automotive applications. I don't find its properties too desirable for automotive application that these things are used in. Let's get that scope turned on. The script got butchered. They changed the script, did they? I wonder, this fan was disconnected when I got it, and I wonder if that's because it was too noisy. I wonder whether the owner has disconnected the fan. Alright, so let's go to change the scope settings to 5 microseconds per division. Reject low frequency, 20 volts per division as well. So let's just see what's happening. So we should have low side drain. I think it's over here. Yep, so that's high and that's low. High, high. Okay, let's just put some glasses on, because just in case something decides to go bang. Let's see where we have Class D switcheroos. And we do have Class D switcheroos. We have 2 amps idle current draw, and that is looking fresh and funky, ready to go. Excelente. I don't know if this is using the 2092s or the 20957s. I suspect it's using there's a way we can check. Now, there's a really interesting side effect of using IRS 2092s in an amplifier with a single positive rail voltage, and that is that the rail voltage itself directly affects the duty cycle on the low side, on the Class D switching side. So if we power it up just now, you can see here we have 52% duty on the scope. Okay, 51, 52. So as we increase the rail, which in the same as the power supply, as we increase the voltage here, if the duty cycle reduces, then this is 2092s. It doesn't. We're still at 52%. This looks like 2092s though. Have they found a way around it? Or is it, maybe, oh no, hang on a minute, this is the, no, this is a clone of the sound digital circuit, so this is 20957s, yes, so that's why. So 20957s, we have a fixed duty cycle. If it was using 209.2s, we'd have a varying duty cycle with rail voltage. Too much diversity parts spoil the real thing of Snow White. So you're not happy with the ethnic diversity of the cast? I mean, that's a bit of a hot take, I'm not going to lie. I wouldn't go shouting that from the treetops, if that's your views. But yeah, seems good. So we can whack in some adhesive now to seat that down. To prevent that from happening again. I mean, it might. It's like a massy kind of thing hanging up in here. So actually, you know what? This is some different adhesive that I don't think I've used before in amps. I'm just going to check to make sure it's not conductive. So let's grab the multimeter, put it onto 2 mega ohm, and just make sure that there's no. Well, actually, there might be when it's wet, but when it dries, it shouldn't be. Ah, there is. Right. So this is a little conductive here. Okay. Oftentimes glues are, because they have water in them, and then when the water evaporates and it stops being conductive. What I can do though is I can check some of. I do have some of this which has dried. For example, on the nozzle here actually. So there's some of this stuff which is on the nozzle here which is dry. So I'm just going to go ahead and probe the resistivity of some of this which is dry. To confirm whether we are safe to use it in the amplifier. Okay, so this dry stuff, the probes are right next to each other, and we have no resistivity, even with the meter on 2 mega ohms. Let's just check this stuff further up by the tip. Yeah, okay, so it's only conductive when it's wet, which is very normal for adhesives and glues. That's actually the same with the regular kind of silicon mastic stuff that you'd use anyway. So that's cool. As long as we don't power it up just now while it's still wet, then it shall be good to go. I'm going to smush this down with my hand in a minute. Once that's done, I'm just going to get it all loaded up. It's going to look messy, but it's going to be a lot more secure than it was. I'd rather have messy and secure than neat and not secure and dying again. We can use this capacitor here as a kind of thing to secure it to, because this cap ain't going nowhere. That is nice and sturdy, that is. Okay, there we go. Very good, very nice. That'll do. From what I heard, the dwarfs are straight up CGI. Yeah, see, I have seen it. I went to see it today. And initially when the dwarfs came into shot, yeah, I was kind of a bit like, whoa, okay, I'm not sure how I feel about this. They're a bit uncanny. They're a bit uncanny. You know when something's like very not realistic, that you can kind of relate to it bit better, like, you know, very, very cartoonish things, very abstract things, because it's so far from realism. Your brain kind of fills in the gaps and kind of you can relate to it, right? And the same way is if something is extremely realistic or is real, then again you can relate to it. But there's this kind of bit in between where something is almost real but also not, and it just kind of makes you go like, whoa. So initially when the dwarfs came into shot, I was like, damn, this looks like AI. It looks like AI generated. I was like, not sure how I feel about this, because obviously the rest of the film is like fully live action. You know, there's all the animals are CGI. They look a little bit strange at first as well. They're like overly cute, like kind of very pushed, very, very far, unrealistically cute kind of vibes. I was a bit like, this kind of gives off AI generated vibes, but you kind of get used to it, and it's all right. Just watched The Electric State with my kids. Don't think I've seen that one. Mr. 18, that's van is next level. Oh, the van is next level. Thank you very much. Appreciate it, man. It's yeah, I don't get to drive it much, but I might be driving it a little bit again this year. One last year before I sell it. What's your thoughts on a Surge Audio 3K? Not sure, because we don't have that brand in the UK, but I guarantee that Surge haven't designed the circuit themselves from scratch, so it will be just, you know, the same as something else that I will have seen. So if you want to send me a picture of the guts to my Bearvids Facebook page, then yeah. Oh, EXO's van is sick. Sorry, I think Mr. 18, I think you're referencing EXO's van maybe rather than mine, but I've seen little bits of it here and there. I don't actively follow a lot of YouTubers. I don't actively watch every single one of EXO's videos, but I do drop in occasionally here and there. And yeah, it looks pretty awesome what he's doing. If it was a new original, not a remake, would you have the same view? Good question. So obviously I have a preconception about what the dwarfs should look like and the kind of magic of the whole animation from, you know, the original. I think I would like, I try to kind of disconnect myself from the original cartoon a bit, and just look at it at face value, and they're still a little bit weird. They're ultra realistic, almost too realistic, and obviously dwarfs that look like that with those proportions don't exist in real life. So your brain kind of goes, whoa, something is wrong here. What's going on? You can't quite. They're too realistic for your brain just to be like, oh, well, this is just make believe. This is just like something, you know. This is just art. Your brain. It's slightly too realistic looking for your brain to be like, that is art. And not realistic enough for your brain to be like, well, that's normal. So that your brain kind of feels a bit strange about it at first. But yeah, after like the first scene or whatever, you get used to it. Do you know Simon Vo too? Of course I do, bro. He's been on the last few live streams with me. Do you have an NX 6000D? No, I do not personally, but I have repaired them before, so I know what's inside them. I know how they work. I know what they are. Do you or Sam or anyone else have any experience with Dayton UM18, the Ultimax? So the 18 is pretty cool from what I understand. The older, they brought out V2 now, but the original Ultimax 18 is one of the ones that I think people recommend. People don't recommend the 15. I think what it is you got the 12 and the 15 share the same motor and coil structure, right? And the issue with the 15 is that it kind of requires almost as big of a box to work and do good things as the 18 does. So you might as well just get the 18. I think that's the issue with the 15, is that it needs too large of an enclosure to do good stuff. So the enclosure requirements are very similar to that of the 18. So then you might as well just get the 18. I think that's the consensus around the older 15. So the 18 is pretty good. Yeah, it has a bigger motor and coil structure than the 15 and the 12. And yeah, performs really well. People love it. People love the Ultimax 18. Did you fix the crown for Simovo too? I did. So I fixed his one just by whacking in a replacement transformer. If you saw my TikTok, you'll see that that's what we did. We managed to get hold of a donor board that had a functional transformer, so dropped that in, and that was all working fine. We bench tested it on my live as well, on my TikTok, sorry, and that was all good. But something else on the board failed shortly after. I think it was like a couple of weeks after Simovo 2 got it back. Something else in the switch mode power supply failed. So, and I haven't had it back since, so I don't know what that was, but yeah, it worked for a couple of weeks, but then something else inside failed, which I'd be interested to see. You know, what else was it that was weakened or damaged in the original failure event? But I haven't had it back yet, so I don't know. But I do still have the donor crown XLS up there on the racks that I need to rewind the transformer for. So Sinewave's original transformer I do have here, and I bought some more laminate wiring for it so I could rewind the transformer and then make the donor amp back up and running again, but I just haven't got around to that yet. It's quite a long process. The 15s were a letdown. I also had the reference HO 15s and they were okay, but didn't last long. Yeah, I don't really know. I personally haven't used Dayton drivers much, so at all. Actually, have I used any Dayton drivers? I'm trying to think if I ever used a Dayton driver. I think the only Dayton drivers... No. Of course, I've used the Neodymium 4-inch drivers. I've got a couple of them here. So I've used Dayton Neo 4 inches, and I have some of Dayton 2-inch drivers for Boomer Bus Season 2, so I've got those. But in terms of like actual subwoofer size drivers, 10s, 12s, 15s, 18s, I don't think I've actually used any Ultimax drivers or any Daytons for that matter. Do you think the 18s keep failing because they're being run sealed in car audio use? I personally haven't heard any stories of them failing, but that might just be because I don't look for the stories or I'm not in the right groups or something, but yeah, I'm not sure. Can't really comment on that because I haven't seen any information or any post about that or anything. But if they are failing, being used in sealed enclosures in car audio, then yeah, for sure. They're not as ruggedly built, you know, they won't take as much abuse as a lot of car audio subs will, just based on their assembly and also, you know, their power handling and stuff. And also any driver used in sealed, if you're playing frequencies under the air spring of the sealed box, then you're basically just trying to push against a vacuum. You're just trying to expand and compress air against what it wants to, which is very hard work. It's going to suck a bunch of power and not really be very loud for how much power is going into the driver while it's doing that. And also in a sealed box, you can't smell the voice coil overheating, you can't smell the coil burning because it's all happening inside the box. So very easy to accidentally blow a sub playing low frequencies when used in a sealed application. I love the feedback, by the way. Thank you. I'm contemplating having the Daytona rebuilt. I'm making a twin box wall for my Forester, or changing brands and going to the Resilient Sounds Platinum 18. Nice. Yeah, you can't really go wrong. The driver selection in your setup is going to be the thing that makes the least difference. So really, anything, you know, the most important thing is going to be the enclosure, the build, and then the power, and then the setup, you know, the crossover points and everything like that. Positioning and build and power are the things that are going to make the most difference. And then you could kind of pretty much throw in any driver within a certain range of parameters in that build, and it's going to sound pretty awesome. So yeah, it's going to make the least difference. So just go with whatever's makes most financial sense for its performance and whatever's available for you, and also just what you like. There's a lot to be said for liking how a woofer looks or the feel of it, because that will actually change how you perceive it sounds. Weirdly enough, our brains are strange like that. If you love how a sub looks, and you love how it moves, you love how it looks moving, and you feel good about a driver, then it may actually sound a little better to you, just because of the human brain doing stuff, than a driver that you don't like how it looks, you know. All right, we are almost back in the heatsink with this one. And then once we've done this back in the heatsink, which is about 5 minutes away, then we're going to be working on the Bassface and doing the modifications for that. Are you excited? Let me hear you say. We have some new output MOSFETs to go into the Bassface. We've got to repair the drive circuit. We've got to drop in some new output inductors. We've got to beef up the traces. We're going to be looking at the Bassface and seeing what things we can do to extract as much power of it as possible. Did everyone hear the sound that the Bassface made on Sinewave's camera? So basically, during the live stream, when the Bassface failed, he was using a camera that had noise suppression, so you couldn't actually hear the sound that the amplifier made when it failed. But he was recording separately on his phone, which did pick up the sound a lot better. And I played it on a live the other day, a bit earlier on in the week. I played that clip for everyone to hear. But if you haven't heard that, let me know and I'll play it again, because it actually made a pretty loud sound when it failed on Sinewave O2's bench, which you might want to hear that still. Where did I just put my screwdriver bit? Not in the back here. Yeah, okay, I'll replay the sound effect. Just give me 1 sec. Where have I just put this screwdriver bit? Okay, well, that's just disappeared. No worries. We'll use another one. Oh wait, here it is. Here it is. Got it. Got it. I got it. Should a some EX6000 be able to come on using only half of the power supply, i.e. one transformer? No, probably not. Those amplifiers are very sensitive to the MCU in detecting the correct amount of rail voltages built from the health check pulses. So no, it probably won't come on. You do need all of the power supply MOSFETs, or all of the banks of the power supply switching it usually in order for those amps to come on and idle. I've been looking forward to how the new Bassface stuff is built and what your thoughts are on it. So yeah, I haven't seen anything super new from them recently, but I think, well, I'm hoping that they will send me prototypes to look at before they release them, because too many UK brands are releasing too many amplifiers with absolutely awful, avoidable design flaws from the factory, because the factories just have no idea what they're doing for some reason. I don't know what's going on, but there's just this massive rushed design going on, mismatch of schematics being shoved together in just like, screw it, it works hopefully, and whatever. There's just a mess going on at a lot of Chinese factories at the minute for car audio, and they're just outputting absolute rubbish that's very poorly designed and has loads of issues. Right, so there's the sound, amp pop. Here you go, you ready? Have a listen. It's towards the end, so we're dynoing, and then, you hear that? Click. Let's play it again. Ready? a big click sound. And that click sound was the output MOSFET leg fusing open, which you are about to see the results of. If we get the Bassface on the bench, here it is, the Bassface 5K. Right, so let's crack this open now. As you will know, because I mentioned it before, so when I did the when I changed the transformers on this amplifier to higher voltage ones, I just threw in some output MOSFETs which were salvaged from a Taramps Smart 5 that had failed. But there were surviving FETs because, you know, this amp was just to play around with and to send to sine wave to see what was going on. So yeah, I didn't put any brand new expensive FETs in because I didn't have any. I just had some salvaged ones from the Taramps Smart 5. I just wanted to see what they would do, see if they had any life left in them. And as you saw on sine wave's stream, they didn't have a super lot of life left in them. I think we got about 4K, 4.5K out of them before one of them or more than one of them let go here. So we're just going to get this out of the case. We're going to get rid of the salvaged 4127s, and then we're going to drop in our bad boy new MOSFETs, repair the drive circuit that probably needs repairing, and go from there. Yep, that's fine. Have you seen the new Ruthless 10K? No, we don't get Ruthless in the UK either. So many brands that you guys in the States and other parts of the world will have access to that we just don't get in the UK. The car audio scene in the UK is abysmal. It's basically non-existent. It's rubbish. So yeah, unless companies want to send me stuff from the States to look at, I don't get around to seeing it, unfortunately. Right, that screw is not wanting to come out because it's just spinning in the hole. There we go. A bespoke design from S&I. I would be curious to see what they have done, because a lot of the recent stuff coming out of Korea for like modern full bridge stuff has not been very good. Xenon have not really done a very good job with their kind of modern attempt at a modern kind of full bridge modern components amplifier. So I'll be curious to see what S&I have done. On OBS. 1212. Are we back? Are we back? Yeah, we're back. OBS disconnected there for a second if it started buffering. Apologies for that. I have the 03L7 Solo X18 Prototype B. Damn, that's pretty sweet, man. That's a flex, that is still. I'd say it was an even bigger flex if someone has the DDZ6. Who's got the DDZ6? Someone's got it. Someone's got the Z6, and it ain't me. I'm curious to see what boards or brands they use in JP's lineup. I don't know where JP's amps are built actually. I think they're built in Korea. Maybe they're S&I. Right, almost out of here. Lovely jubbly. Okay, hey, there we go. See you later, heatsink. We'll be seeing you maybe in a bit. Who knows? Right. So let's just get these salvaged 4127s. Let's just cut these out. Like, they ain't going anywhere again. They've already been in a Smart 5 and they've already been in here. Let's just get these ones out of here as well. Did we kill any on this side as well? Probably not. Alright. Let's get the soldering iron on and get these out of the board. Sound is cutting in and out. Why is the sound cutting in and out? Alright. Okay, I've swapped microphones. You've now got the old school JVC Handycam mic, so it's going to sound a bit different. But let me know if the sound still keeps cutting in and out. Because if it does, then it's something to do with OBS. If it doesn't, then it might be something to do with the microphone on the stream cam on my head. Actually, which microphone do you guys prefer? Do you prefer this one, the JVC, with a bit of background ambient noise? Or do you prefer this one, which is more personal, up-close kind of sounding audio? Second one, this one that I'm currently on. The voice definitely sounds nicer. Yeah, head cam 100%, yeah, no worries. I know that some people miss the ambient noise of the oscilloscope in the background. It's kind of a bit of ASMR for a few people that have been here for years. I don't think you can hear the oscilloscope on with this mic. Jordan says, so this Stetson that he's working on, hang on, let me just get this out. Need some different tweezers. Alright, there we go, come on, out you come. There we go. Jordan says, this Stetson that I'm working on has all new power supply FETs, but waiting on one driver for the power supply. It doesn't even try to do anything. No, it won't do. It won't do. You need all of the power supply FETs switching on these amps to actually get the amplifier to come out of health check mode. That's pretty normal. What is it, William? Why are you saying my name, bro? Why are you calling my name for, huh? Sinewave02, Mr. Donnell. Are you here in the live chat? Let me know if you are. Are you still in Haysbro? Are you still with Manaman like Shane? Or are you back at Yard now? Jared, Sam is amazing. Thanks for the help. Man, I appreciate it. No worries. Glad I can be of help. I ain't even heard of anyone in the scene other than the pages have JP amps in the UK. I haven't seen any JP amps for repair ever. Not a single one has crossed my bench. So I don't think there's many of them in the UK. On the first mic I could hear the sound of cars passing by. It's actually trains. I'm pretty close to a high-speed train line. So I could throw a fishing rod and tap into some high voltage, high current train power if I wanted to. I think the overhead train lines run on like many thousands. I think it's like hundreds of thousands of volts. I think the power that's in the third rail runs on like, I think it's like 400 or 500 volts. It's not quite as high as the overhead lines. Bevids, are you on Discord? I am on Discord, but I barely use Discord. I forget it exists. It's just one too many social media chat platforms. You know, I wouldn't say I'm chronically, what's it called? Chronically online? I wouldn't say I'm chronically online type of person. I'm always just doing some stuff in the workshop and that, so I don't spend a bunch of time on Discord or any other apps, but I am on there. So if you want to chat to me on Discord, you can tag me and I'll get a notification and then I'll jump on, but I don't tend to sit on Discord for very often. Jordan says, I got it. I thought I would at least get flashing fault lights. So what do you mean you get no lights whatsoever? You should have some lights. You should have a protection light, and you should have the health check status should go through the LEDs. If you're not getting any of that, then it's possible that whatever a voltage regulator is supplying the MCU with power has failed. So you might need to check that the MCU is getting its 5 volts. I think they run on either 3.3 or 5 volts, depending on what the chip is. And you should also get some pulses being sent to the power supply FETs that you have in, and it should build a little bit of rail voltage even when you haven't got all the power supply FETs in. So you should have definitely some signs of life and some stuff happening. If you get absolutely nothing happen, no lights, no pulses, no signs of life, then there is still problems and the power supply driver won't fix that. Does nothing. Yeah, okay, so yeah, you have other issues there, my friend. You're going to have to look into the remote turn-on circuit, follow back from the remote power-on terminal, also trace back from the MCU's VCC pin. You can get the data sheet online. Just type in the model number of the MCU that you've got. See which pin is the VCC. It's often it's pin 1. So trace back from pin 1, see where that comes from, and diagnose why you're not getting any power to the MCU. Alright, so all of those old ass FETs are removed. Now what we need to do is repair the drive circuit, because when this was at Sinewave02's on his bench, I did get him to just cut out the dead FETs, and it was still going into protection. The amp would come on with like 1 remaining FET per bank in the output section, but yeah, it wasn't coming out of protect. So it looks like we probably have dead drive circuit. Now the side of the amp that failed was this side, if I remember rightly. So let's just have a quick check with the multimeter. Get some readings. So we've got some drive buffers here, IC13 and IC14. Let's have a check of some readings here. So this is the good side. I'm just checking we have continuity on those two, continuity on those two. Yep. Now what we shouldn't have is continuity between, I don't think we should have continuity anywhere between these two sides. No, we shouldn't. Okay, so we do have continuity there, so that's toast. That one maybe is okay, but I'm going to replace them anyway. So let's get the hot air gun turned on, because that's bad, and maybe this is bad as well. 20957. The 10 ohm resistors in line are still okay. 15 volt Zenas here sometimes go bad. We have got 84 ohms. I wonder if that is across the Zena or if that's across this chip. So we're going to remove the chip to find out. That one there seems alright. Okay. Now what about gate resistors? Do we have any dead gate resistors? So we've got 21, 21, 21, 21, 21. Okay, so gate resistors are all okay. So let's just pull the drive buffer, which is here. Get some flux on the board, why not? Flux it up. I think the train rails are DC. Yeah, so the DC rails, the kind of third rail, power rail, I think is around 400 volts DC. The overhead lines, I don't know. I'm not a train enthusiast, but I think they're in the hundreds of thousands of volts, a bit like power lines are. What do you think of the team stuff from Bassface? it's not particularly good, but at the price that it is, especially the amplifiers, you can't complain. Like, to get a genuine 5,000 watts RMS for bloody £260 brand new, I mean, you can't go wrong. You can't argue with that. It's cool. It's good. 25 kV. Ah, cool. Fair play. So it's not hundreds of thousands. All right. So that low resistance across this Zener has disappeared. Got 485 and got the similar numbers both ways. Which oh, hang on a minute. We jumped up to 506. That's a possible issue. With a diode, we should have different numbers when we put the probes each way around, but we'll keep an eye on that. 320. That 532 that way, and that way's open, so that's what we should probably be seeing. Let's just knock that Zener off of its pad and see what it reads out of circuit. I don't know if I trust that. Speaking of tapping into the train's power, I had a cousin who used to steal electricity. Though he had an entire power company outfit, he would hook others up for a price. Jokes, what the heck? That's crazy. Alright, so I'm just seeing whether this diode is reading correctly out of circuit. Right. Flip the probes. Nah, that's toast, that is, bro. That is toast. That is a toasted diode. See ya. Alright. Now, I believe these ones are okay, but see, this IC14, I'm going to remove it anyway, because we want to replace both of these together at the same time, so they're both the same, just to keep things nice and even. Okay, now how about the IRS 20957? One thing we can do is just check some of the capacitors here, which are on the supply. Let's check the bootstrap diode. This will tell us a little bit about the chip. Okay, that's looking alright so far. This capacitor, that's looking alright. Let's just check there's no shorts between any of these pins. So the drive IC might have survived. Even if it has survived though, I might just replace it anyway, just to give us the best chance of it not dying on Sinewave's bench, just so we've got some all new parts in there. But I will leave it in there for now, just to check that it is actually functional, and if it is, I'll put it to one side for use in something else, because some of these chips ain't cheap, you know, still. So it'd be cool to have one for a little side project or something. Okay. Just freshen up these solder pads. Ready for the new drivers. And we need a 15-volt Zener on there as well. Alright, let's grab some new drivers. We've got some 3006s, I think, from... I think I ordered some of these from good old RS Components. Now what do I do with them, though? I'll put them on the bench here. We've got the new output FETs just here for the Bassface. And I thought I'd ordered some of the drivers as well. 3005. Yeah, I'm pretty sure I had ordered some drivers. What have I done with them now? That's the output FETs. That is an empty bag. Half bridge, rectifier, NPM, PSP, 2401. Got some 20957s, okay. Alright, well, let's use these two 3005s. Let's drop these in. This is some tiny stuff. Do you have schematics for these amplifiers? Hell no, bro. I do not. I never use schematics really. Very rarely I use a schematic. You can see what these circuits are doing just by looking at them, to be fair. These are not complicated. These circuits barely deviate from the datasheet examples for like the 2092 and 20957. They're just the datasheet example circuits with some MOSFETs and a filter network shoved on. Alright, let's drop in a 15 volt Zener in that location, the one that failed. There we go, there's a nice 15 volt. Nice, nice. And then there's a couple of things I want to check. So basically, as I covered on my very long 1 hour video of this circuit on YouTube, which is I think it's like clone amplifiers repair video, full walkthrough. These diodes by the output FETs can die, and you can't read them in circuit because you've got some 4148s which are in parallel with the gate resistors. You can't read those in circuit. And you've got some 15 volt Zeners which are all in parallel with each other, so you can't tell when one's bad. So the best way to do this, to check them, is to just remove the gate resistor, or just lift the gate resistor off one of its pads like this. And that then allows you to read all of the diodes, because the Zenas are no longer in parallel through the gates, and each one of the 4148s now is no longer have a resistor in parallel with it, so you can read all of them. So we're going to go ahead and check the Zenas first. So we should have, the numbers will be slightly different because of we just heated it, but we shouldn't have readings both ways around. So we've got 13 that way and 630 that way. Okay, let's go on to the next one. 6 that way. Yep, that's looking good. 13 that way. 6 that way. 14 that way. Ah! Now this is what I'm talking about. You'd never know that. That Zener diode is completely open. But you'd never know that unless you lifted the gate, because you can't read it in circuit. So we've got high value both ways round. We should have a reading around 500 to 600 with the black multimeter probe on the side with the line, which we don't have. So that's dead. That's a dead part. You never know that. You'd never know that. So take these tips and use them if you're repairing these type of amplifiers. Do these Zenas have to be in a specific position? Yeah, they've got to be the correct orientation for sure. You can't just put them in either way around. They've got to be in the correct orientation. Alright, let's grab another 15 volt Zener. Where did I just put? I had a little roll of them. Here we go. Another one just there. Okay, so we're going to drop that in, and the same applies for the 4148s, which are in parallel with the gate resistor. You'd never know if those were dead either unless you lifted the gate. So really important when you're working on these, lift all the gates, check all the parts. Right, now let's check all of the 4148s. So for this, we're going across these little 4148s. So we're going black side against there. Right, so here we have this little one here. We have, I think I just saw that correctly. So we should have blocking from the driver side. Come on. I'm pretty sure I saw that was fine. Yeah, 490. Okay. On that one. And this one. We have 480, that's fine. Everything's a bit hot in different temperatures, so slight different readings is fine. And this one, again, oh wait, here we go, 498 on this one, and that's because that's coming, is that coming from there, the drive? Yeah. Okay, cool, so all of the 4148s are actually fine, but this Zener here was open, so good job we found that. Let's put some flux on these gate resistors and get them back in the circuit. Get them back connected up. Alright, sweet. Now, what I'm going to do is I'm going to power this up without any MOSFETs fitted into the output section, because I just want to see what kind of temperature this drive IC gets to. I just want to see whether there's any chance it survived. I want to see how its temperature compares to the one on the other side that definitely did survive. Well, it might have failed because they both might have taken each other out. So let's just get some power into the board and go from there. Make sure there's no solder bridges on the back before we put power into it, and I think we're good. Check the rectifiers as well, because sometimes these can fail. Hey yo, we got a dead rectifier. What are the chances? I just decided to give that a cheeky little check. Rare. Okay, dead rectifier. Well, that's not such a bad thing because it might be a cool idea to upgrade these. What can I put in place? I don't know if we really need to upgrade them as such. Like, even much bigger amplifiers than this use just 4 1620s. So I don't know if we need to upgrade these. Like, it's not going to make much of a difference. It's not going to drop much voltage across them, but good job we just checked that, hey? Crash, see ya! See you later, bro! How do you know the correct orientation with those small SMD components? You just have a look at the markings on them, bro. Fortunately, my eyes are still pretty good, so I can see the markings on these tiny parts without any assistance generally. I'll use the microscope sometimes if I'm just needing to really double check it. Yeah, that's dead as well, that rectifier there. Shee! Man, this went down hard. Yeah, we're going to be doing the upgrades one at a time this evening. So we're going to do the output FETs first, then we're going to do the output inductors just to make sure that everything's happy. And then we're going to look at what else we can do, beefing up traces, that kind of thing. Alright, how about the ones on this side? I might just change all of them for new while we're here. These ones do read okay, but I'm going to change them all out for some fresh new ones that I know are like good, genuine parts whilst we are here, because it would be rude not to. Oh, you're saying goodbye to the other user? My bad, no worries. Just every now and then I glance up at the live chat and not necessarily getting context. I may be wrong, but I feel like many amps have moved to using those square transformers. Why is that? Likely cost. So you know, you can buy those. Well, I don't know. They're probably cheaper to manufacture. I'm not gonna lie. Those square transformers, and I don't hate it. I don't hate it. The square style transformers do seem a bit more resilient to vibration damage. So I don't know where they might not be quite as power dense and as efficient as the kind of toroidal style. They're less susceptible to vibration damage, so that's not a bad thing in my book. Alright, now I've just removed the rectifiers, and I I forgot, I didn't bother to take note of which ones go where, common cathode, common anode, so I'm just going to go ahead and grab... I swear I ordered bare of these rectifiers. Where are they? Maybe they're in this bag. Here we go. What have we got in here? We've got a bunch of resistors for the T-amp. I ordered some just the other day. So we've got bare resistors and fuses for the T-amp in there. What have we got in here? Right, in here we've got some MOSFETs for the T-amp, rail switch MOSFETs, got some power supply FETs, we've got some more chip resistors. Right, so where's all the rectifiers that I bought then? Rectifiers, are they in here? Nope. Right, they should be in here. This is my little 1620 Rex box thing. U1640G. 1640G. I ordered some MUR 1620. 1620RG. 1620RG. 1640G, 1640G. I might have to use 1640s and 1620 RG. The 1640s are just 400 volts stable, and the 1620s are 200 volts stable, but I don't seem to have like equal voltage parts. It doesn't matter. They're both going to be as, you know, the current handling of them is the same. It's just one of them is 400 volt rated, one's 200 volt rated, which the rails here don't exceed 200 volts anyway. So, but I'm sure that I bought some MUR 1620s, both common cathode and common anode, the other day. Maybe not. Just having a look around to see if they could be anywhere else on the desk. That's the output FETs. That's some screws. No. Okay, cool. No worries. Let's just drop in some of these parts. 1640s and 1620s. So in order to get the location correct, I'm just going to, because I didn't bother to check, I'm just going to drop the random part in here and a random part in here, and I'm just going to power the amplifier up with a couple of pulses of the remote wire, and we're going to see if we get any rail voltage being built, and that will tell me whether they're in the right places or not. And if they're not, we just swap them round. RS Components is one of the cheapest places for me. Let's see those beefy replacement FETs. Yeah, I'll show you those in a minute. They're the same size as the originals. They're the same package, TO220, but yeah, I went with some pretty high power models, some high current but still easy to drive parts. So, and they weren't too expensive either. I was quite impressed. They're not that expensive. Right, so power wires, let's just shove that in there, like this. Excellent stuff. That one in there. And yeah, let's put the 1640 in that location, and the 1620 in that location. That should be fine. 1620 and 1640. So we're just going to see whether that builds a little bit of rail to tell us if we got the locations correct for these two. Okay. So let's give the power supply. Let's drop down to like 9 volts, just to be on the safe side. And then we're just going to grab a couple of non-conductive items like these. Okay. Take my oscilloscope probe, shove it in the high side drain, which is going to be the rail voltage, just there. Turn the scope down a little bit to like 5 volts per division. And then just going to push these down with a bit of wood, push these down with a bit, with a bit of plastic. That's a bit of metal. This is why I wanted something non-conductive. Bit of plastic, like I said, a bit of plastic. There we go. And we're just going to pulse a little bit of rail. Let's get a little couple of pulses so that we can see. Okay, that's actually reducing the rail voltage. So they are the incorrect way around. All right, so let's turn it off and flip these around so that they're now in there, and they are now in there. Okay. get our non-conductive things, push them down again. Power on. Now we're getting rail voltage. Okay, so that's the correct way around. Excellent stuff. Little tip for you. If you ever accidentally removed the rectifiers and didn't check which way around they go, that's something you can do. Just a couple of pulses of remote will just show you which way around they go. Okay, lovely stuff. Okay, we've still got 12 volts there on the rail, so let's just dump that to ground real fast. There we go, lovely stuff. One of the younger guys in my local car group really seems to like his Taramps DSP, although I think he just switched to it from an 8-channel from another Brazilian company. Ah, cool. I haven't tried any of the Taramps. I haven't tried any of the Brazilian DSPs, to be fair. Be interested to give them a go. Wonder what they're like. I don't hold out too much hope. Like, my experience of Taramps has been fantastic value for money. Brilliant, well-designed circuits for making a lot of power for not much money. But in terms of stuff that they've done for sound quality, if the head unit is anything to go by, not too impressed. But the full range amps sound fine. Nothing mega special or SQ, but the DSP is, like, you know, tailored for SQ, aimed at SQ, or maybe just system flexibility. Maybe that's the thing. Maybe the Taramps DSP is more for sort of like setting up a big, loud, shouty system, but giving you flexibility with crossover points and stuff like that. So the bench power supply that I use here just for powering these things up to test them while we're repairing. It's current adjustable, and I can go anywhere from 0 to 40 amps. I do also have a 200 amp power supply for if I want to dump bigger power into these amps on the bench. I do also have a bank of ultra capacitors if I need a bit more instantaneous transient energy. And I have also just recently from AliExpress bought some sodium ion cells. Yes, I have purchased some sodium ion battery cells to try out to see how they compare to lithium. They were very, very cheap. Actually, they're very cheap at the moment. Guys, if you're thinking about giving sodium ion a go, grab some now while they're stupidly cheap on AliExpress. They're like mega discounted, the orange ones. You can get 16 pieces for about 70 bucks, I think it is, which will give you 4 banks of, 4 12-volt banks, which is quite a lot of power for 70 bucks. You can't go wrong. You will need to buy a balancer for them, and you'll need to set them up. You need to know what you're doing a little bit, but you can't go wrong for the price. And it'd be interesting to see what this new battery chemistry is like compared to lithium. So I'm going to give it a go. How are Digital Design's DSPs? Nothing special. They don't design or make their own DSPs. They're just purchased in from a factory. So I would avoid. I haven't liked the Digital Design's DSPs that I've used personally. They are not. They're very expensive, and they're nowhere near as good as the likes of the Helix or the JL Audio ones or anything like that. So I wouldn't really recommend them. Alright, let's power this up and see whether we have the drive IC on this side getting any hotter than the one on this side using the good old thermal imager. Now, I have actually reached out to Infraray. I want their new P2 Pro Plus. That looks freaking awesome. I've reached out to them to see whether they'll be willing to drop me one on a donation, on a sponsorship kind of thing, where I obviously, because I'll be using it every day in the workshop, every single live stream I'll be using their thermal imager, and it'll be getting loads of attention and stuff, and they definitely have given them to content creators before, so I'm reaching out to see whether Infrared will be willing to provide one for the content and get some great exposure from my content. So let's power the supply on here. And let's have a little looky, see what we're doing. So let's just confirm rail voltage. The rail voltage is going to be pretty high because we've got these big ass transformers in here, haven't we? Okay, so on this side we have bumping up to, let's just confirm that on the scope there, sort of bumping up from 10 to 14 volts. And on this side we have 10 volts bumping up to 14. So we have the same behavior on both sides, which is good to see. Now, I think the drive ICs are active even when the rail hasn't fully built. So if I just, what are we on with the rail at the moment? The rail is currently sitting at 32 volts. Okay, cool. So let's just have a little look, see whether the drive ICs get warm or not. So even though the amp's in protect, supply voltage should be being sent to the drivers here. So yeah, we've got 15 volts going to the driver there, and 15 volts to the driver here. So yeah, the drivers are getting their supply. Neither of them are getting particularly hot. So yeah, drive IC may in fact have survived. Anything else getting hot? Not really. So yeah, I think this drive IC might be okay. I think I'm probably going to change both of them anyway, but for the time being, I think maybe we'll just leave it. I'm going to go full operation, build full rail voltage just to see what it does. Okay, 135 volts there on the rails. We're powered up fully, full power supply switching as well. And again, yeah, no excessive heat or anything on either of those drive ICs. So yeah, I think we're probably good to go on that one in that regard. We're ready to fit some output MOSFETs and see what these new output MOSFETs are like and see what they're doing. So they are, let's have a quick look at these. Let's have a quick look at these. How long does sodium ion last? I've got no idea. They were so cheap that I couldn't say no. And I'm going to find out. I haven't really done much research on them. I just bought them. So these parts are SUP 901100. No, sorry, SUP 90100E. These are going to be some beefy parts. How close can the stream cam focus? Can it focus this close? Oh, it can. Yeah. Good little camera, this. It goes for the majority though. It doesn't, like, you see it's focused on the background. Even though I'm bringing something very close into the foreground, it doesn't want to focus on that unless I like completely block out the background, and then eventually it will refocus. Now see, it's still got its focus on the background. That's your difference. Sodium ion batteries scare me. Why is that? So tell me about what you're scared of, because I have no idea. I haven't done any research. I just literally pulled the trigger on them because they were very, very cheap and promised a lot. So, but I haven't done any research or anything really on them. So I'd be interested to know why you're scared, what your thoughts are about them, etc. Please explain to us the phenomenon of self-induction in amplifiers. What do you mean? I haven't come across that term before. So can you explain to me what you mean by that? What that's supposed to do? What you mean by that? Self-induction. Do you mean self-oscillation? Do you mean a self-oscillating amplifier? Some YouTube channels already tested the NA batteries. Not very promising in terms of current capability, energy density and lifespan. Oh, really? You know what happens when sodium comes in contact with moisture, right? Nope, not really. Fire, maybe? people using a tiny bank then trying to force 400 amps in them. Yeah, I guess we'll see what they do. Guess we'll find out together. Yeah, lithium doesn't like being in contact with water, does it? Either. So yeah, same issue there. So that's no different. Nothing new. Alright, that's 4 output FETs in that side. Just dropping 4 in on the other side as well. I think I've got 2 spare, just in case something goes wrong as well. Oh, 1 spare. 1 spare. So once these FETs are fitted, we're going to test to see how the drive circuit behaves and whether it likes them, whether these like being ran in this circuit at the frequency that they're running at, etc, etc. If everything is happy, then we have some better output inductors to go in here from the SFB13K. So that'll be fun. Whack those in. They'll look pretty big and beefy in here, I think. Then we can beef up some of the traces, some of the main power carrying traces. And it would also be cool to change the switching frequency of the power supply, but that's going to require some messing around with injecting a TL494, which we can do, but I don't know whether there'll be many gains to be had from running a lower frequency on the power supply of this. I don't know how. See, the thing is, I don't know how much room there is in the power supply of these transformers to run at a lower frequency, because to extract more power from a transformer, switch mode power supply transformer in this case, you want to lower the switching frequency, which is actually backwards to how I thought it was for a long time. I always assumed that you needed to increase the switching frequency of the transformer to increase its power throughput before saturation, but apparently it's actually the other way around. You want a slower frequency. So we can use, obviously this has an MCU that generates the pulses, and to change the frequency we'd need to change the firmware, which we can't do. So we can retrofit a TL494 or some other oscillator to set our own frequency for the power supply to oscillate on. Just a little bit involved, that's all. I don't know how much more power we could really extract by doing that. Don't know if it's worth the effort or not. Okay, so that's all of our output MOSFETs soldered in place. So now we're going to power it up and just make sure that the drive circuit works to start with, and then make sure that these MOSFETs are happy in this circuit. So yeah, I guess I'm going to whack a load across the terminals, the speaker terminals, just because these amps don't like really being idled without a load. So we just want to make it be as safe as possible, because these MOSFETs, they're not super expensive, but they're not like mega cheap either. You know, we don't want to kill them unnecessarily. So let's just drop a 4 ohm resistive load across these speaker terminals here, just in case something is weird. Swirl, how was your day, bro? Yeah, my day was pretty good, thanks, my friend. How was yours? Had a good day today. It's still a good day. It is still a good day. Alright, cool. Fire in the hole. Power up and see whether these FETs are happy in here or not. Let's just do a sanity check with the multimeter. Check everything's alright here. No solder bridges or anything. Uh, 551, 631. Ooh, very different numbers actually, this way around versus this way around on here. Yeah, okay, we've got very different values between each side here. You know what I think I'm going to do? I think I'm just going to go ahead and change the 20957S's anyway, because I'm going to do that regardless. Because I want 2 fresh ones in here that are both the same. So I'm going to do that just now regardless, before we power it up, just to be on the safe side, you know. So a couple brand new ICs, just to be sure. So changing the switching frequency of the transformer doesn't raise the voltage. It can affect how much power the transformer can pass before saturation. There'll be a frequency range that a transformer is most effective within. And apparently if you lower it slightly, you can, you know, the slightly lower window in the transformer's operational range allows for slightly higher current throughput compared to its higher window. Yes, you know what? I think actually maybe one of these drive ICs was dead, because the readings have now evened out between these high side banks. And obviously we've got drive buffers in the way, but the main drive IC will have a connection to the FETs via high side drive. So I think that there definitely was an issue there with one of these drivers. So it's a good job that we changed them just now. Just good job that we spotted that. Is this for customer or are you loading this into a vehicle? So this is just for fun. This is for a fun experiment between myself and Sinewave 02. And yeah, this was a customer's amplifier. It had a shorted transformer, which you can't get new transformers for these. So I offered the customer a whole new board, which you can get from Bassface, but it was too expensive. Wasn't worth doing. So that I just ended up with this amplifier. But I had some transformers from a Sundown SFB 13K, so a much more powerful amplifier. Doesn't mean that we can immediately make this amp more powerful, but it means that the rail voltage was higher. So I just messed around doing some modifications to this board to make it stable at a higher rail voltage using the Sundown SFB transformers. And then me and Sinewave just got the idea that we should see how much power we can get out of this with a higher rail voltage by doing some modifications where I do some mods, send it down to him because he's got a really big power supply for bench testing these amps. So I do the mods and then we send it down to Sinewave to do the bench test on live so you can see the bench test happening and see if it fails or blows up. So that's basically what we're doing. Just doing some mods to see whether we can get some more power out of this. Yeah, just for fun really. Alright, let's just confirm that all of these legs are nicely soldered. I believe so, they look pretty good. Looking good in here. Yep, that's cool. Didn't you have some server power supplies for testing amps back in the day? Yeah, I still got them here, but I haven't hooked them up in years. One of them's actually dead. I killed one of my Dell server power supplies by accident. It wasn't even powered up. But basically, back in the old workshop, maybe 5 years ago, I had two sets of wires by the workbench. Okay, they were both the same type of wire. They were both blue speaker wire. Now one set of blue speaker wire was connected to a big 16 ohm dummy load resistor, and I used those wires to discharge the rail voltage in amplifiers after powering them up and powering them down so that I could then safely work on them. So I used to get my two big pieces of wire and I used to dump them across the rails, sometimes 200, 300, even 400 volts worth of rail voltage I would dump through this resistor bank, boom, like that, to make the amp safe to work on again. The other set of wires on the other side of the bench, which were exactly the same type of wire, were connected to my Dell server power supply. And then you can see where this is going. Yeah, so one day I grabbed the incorrect wire, I grabbed the Dell server power supply wires and shorted out the rails on a big powerful 300 volt rail amplifier. The power supply wasn't even plugged into the mains, but obviously the 12 volt output section of the server power supply getting 300 volts DC all of a sudden, yeah, it wasn't too happy about that. So that's got some dead components in the output section of the server power supply as a result of that mishap. And I haven't even bothered to open it up or have a look. I just, fuck it. I never use them anyway, so it's fine. I'll fix it one day. So I do have a sponsorship lined up for PCBWay, but I haven't done anything with it yet because I can't think of like what I could do. PCBWay have reached out and said, hey, yeah, we want to work with you, and it would be a great opportunity for me to design something and get some circuits out there. I'm just not sure what of. Like, designing an amp, it feels like too big of a project right now. I want to start with something smaller. I've had the idea to make a really cheap clip detector with the same logic as my little idea years ago with the little speaker and the inline capacitor that buzzes. My idea was to make something that uses the same basis of that but with an LED instead, or just something simple like that. It could be a clip detection circuit that you can add to any amplifier. So that's one idea that I could do. I just haven't got around to designing that yet. I've got other little side projects that would be cool to work on. Would love to make some Encore. What is an Encore? Is that like a PA amp? Okay, so with those we're swapped out now, we should get equal multimeter readings. or equal-ish. 10, 5. No, we don't. They're still different. What's going on? Maybe it's because of the drive buffers are different. We've got 3005s on this side. Okay, well, I'm just going to roll with it and turn it on and see what happens. I'm really cross because I definitely ordered some little drive buffers from RS. But where did I put them? Like, the only place I would have put them is in this half-bridge drawer. But they're not in here. So I don't get it. Right, power supply PNP, they're not going to be in here. Nope. AKG 414, D drive SOT 23, they're not going to be in there. Brazil FETs, 465 rectifiers, old drivers, nope. Half bridge 2010s, nope. Rectifiers, 2X2Ts, rectifiers, 4145s, regulators. Did I put them in here by accident? Nope. Nope, that's just voltage regulators. Nope. Ops couplers. 21844S. Nope, not in there. 2092s. Nope. Yeah, I don't know. Kind of annoying. Because I'm almost certain that I ordered some of those drive buffers, but so at the moment we've got uneven drive buffers. We've got like 3005s in this side, and we've got UCC drive buffers in this side. They're separate amplifiers, they are separate channels, so it shouldn't matter, but just the OCD in me is just wanting them to all be the same, and I'm sure I ordered some so that I could make them all be the same, so it's just kind of frustrating that I either didn't order them, or I put them somewhere safe that is now not known. But yeah, anyway, we're just going to power up and see what happens. So 9 volts going in. Got high side here with the rail on it, so let's just build a little bit of rail. Nice, nice. Okay, let's probe the low side drain there and get my glasses on just in case it's not happy and something goes bang. Okay, here we go. Okay, so something's not happy. We got a little pulse there. It tried to start Class D switching and failed. Okay. Why did you fail? 48. Okay, so I'm not going to try it again, just in case. Okay, so where do we go from here? Where do we go from here then? So it tried to initialize Class D switching, but it failed. So we can put the amp into service mode, which will force. I'll tell you what we can do actually. Yeah, easy. We just remove these diodes, which will force the output side to try and start switching immediately, even with low voltage rails. So that's what we're going to do. I'm just going to dump the excess energy in the rail caps, and then we're going to get the amp powered up with like no rail present. Let's turn that power supply off. Okay, the rail voltage is gone. I don't even know if there was any rail voltage in there. I think there definitely was. A bit of flux on these diodes here. They're an amazing Class D. Oh, really? Okay. They sell modules, but no power supply for car, only home. Maybe we design some then. It shouldn't be too difficult to design a switch mode power supply for that. They're pretty simple, basic things. Right. Okay, so now we've removed those diodes. This should try and come on and oscillate with no rail or barely any rail. So we're going to allow only like 5.5 amps in. So let's probe the low side drain up here. Okay, look there you go. Right, we have Class D switching and it seems alright. It's not drawing current or anything, is it? So why did it, like, fail just now? Why did it fail to build? Because this is definitely fine. Like, that's definitely working. So what's the problem? Right, with that powered up like this though, let's check all of the gate drives. Let's check all the gate drives. Right, so we've got low side drive over here. Right, that looks beautiful. Pause, move over, run. Looks beautiful. Pause, move over to the other side, run. Looks beautiful. Looks beautiful. Right, that's all looking good. Right, let's check the high side. High side drive, looking good. Looking good. On the other side, looking similar. Looking similar. Right, so there's nothing here. There's no issues, no reason why this didn't come on a minute ago with the full rail. Right, let me just confirm. Let's do a sanity check. Let's just Google these parts to make sure they haven't sent me the wrong parts. SUP 90100E. Right. SUP 90100E. 200 volt MOSFET. Yeah, this is correct. 150 amp. Gate charge. Right, the input capacitance isn't crazy high. That's cool. The total gate charge isn't crazy high. That's cool. They're not super slow. So can't see any reason why this didn't come on just now with full rail. Very, very strange. I guess we just try again. But I didn't like the way that it kind of clicked to try and build Class D and failed. It should have just done it with no complaints. Because there's definitely nothing wrong here with this, as just proven. Big Jeff, love catching your lives. What's going on, bro? Good to see you here. Thanks for jumping on. So, quick sanity check one last time. We have D27 with the diode this way round. That's correct. Reading 823. This way round 590. And this diode here, D16, that's the correct way round as well. They're both 15 volt Zeners. So we shouldn't really have any issues here. We should just be able to power up and it should just come straight to life. So again, probe low side drain, 50 volts per division, build a bit of rail. Okay, there we go, build a bit of rail, and it should literally just come on. Whoa! No, it did not. Something failed. Why? Why? Power supply failed. Did you see that? On this, the big click sound. I'm so bamboozled right now. There's nothing wrong with this, as proven just now by the fact that it just ran fine with low rail voltage. Fuck! Got dead outputs on this side. Why? And I think that killed the power supply FET as well. Maybe, I don't know, maybe not. The power supply was like, was cooking. I am so confused. Bro! What is this? What is this? (4148) diode, not attached. I haven't touched this side of the board though. Could that be the reason? I wouldn't have thought it would die so quickly like that though, from just the 4148 not being there. I didn't see excessive ringing though. I didn't see excessive ringing. Right, well we have one spare from new, but I think there's more than one that's dead, unfortunately. We've got that one there. That one seems to probably be okay. That one there's dead. So we've got at least this one. And this one. Right, these two. Nope, they didn't survive it. We've got 3 dead. Is it 3 dead, or is that just after the gate? 22, 02. Ah! Okay, the driver on this side has failed. The drive buffer. Man, a whole bunch of stuff just failed. Literally. Jesus. I think this has got to be the first time in months that I've had something like fail on the bench. Obviously, having the low current power supply means that this stuff shouldn't really happen. But obviously, we've got a lot of energy stored in these rail caps, and when it started switching high voltage, then something just was not happy. So unfortunately, we can't complete the modifications tonight because we have more dead FETs than we have. So I'm gonna have to order some more. And just a bit bamboozled by this failure event. I wouldn't have thought that one slightly lifted 4148 diode would cause this much catastrophe instantaneously, but maybe it would. Who knows? So we're going to have to go from the start again now, basically on this side. So we're going to have to remove all the gates, confirm the 4148s and the 15-volt Zenas, because yeah, this is failed freshly. So anything could be wrong now on this side. One of the new drive ICs we just fitted, we're back kind of back to square one, but on this side. So we're going to remove the gate resistors, confirm all the Zenas, confirm all the 4148s. I mean, it's possible. So the 4148 diodes that are in parallel with the gates, they allow the MOSFETs to turn off very quickly. With the gate resistor in series, the MOSFET on this side may have been left on for too long, and therefore it would have cross-conducted. And if the cross-conduction was high enough, enough, then it would have definitely caused the rails to basically dump through the FET, which is very unfortunate. So 4148 on this side. Let's check this one. Okay, 4148 is okay. Zener diode. Right, that Zener has failed. So we have a failed Zener just there. So one bad Zener. That 4148 is okay. It wasn't even connected to the board, so it should be. Right, this Zener is bad. Oh no, wait, is it? No, I just wasn't pushing down hard enough. Right, this Zener's okay. That Zener's okay. This one is bad. This Zener is bad. This one's okay. Right. Bloody hell! So shipping for parts is next day here in the UK because everything's located in the UK. So yeah, I order one day and they arrive the next day. I shouldn't have powered it up again, should I? Like, I should have just not powered it up again. What a dickhead. I'm going to swap out all the Zenas on this side, actually, like, just so that they're all the same. Why not? I think I've got enough, so it'd be rude not to. Hot dang it! Hot dang it! I will be able to power this up again though this evening because I do have enough FETs for, you know, one per bank, just to kind of show that the drive circuit works and everything. But I don't have enough to send it down to Donnell just yet because I only had one spare from the order. Right, there's some 15-volt Zenas. One, two, three, four. So for anyone just joined, we fitted some new MOSFETs to this. We checked the operation of the amplifier on low voltage with low voltage rails in a kind of health check mode, in a kind of service mode. Everything was perfect. All the drives were identical between banks. Everything looked great. Everything looked ready to roll. But when we powered it up with full rail voltage, it didn't even try and switch once. We just had a big click, a big failure event, and we lost two MOSFETs, drivers, Zener diodes, and all sorts. So very frustrating, but that's the way it goes sometimes. We found one 4148 diode that wasn't quite soldered properly to the board. I can't imagine really that would have caused this much of an issue, but it maybe did. It's hard to know really for sure. Alright, so that's the Zenas replaced. Let's put the let's put the gate resistors back in place. Now I do have one FET per bank left here, which is fine. So I can power the amplifier up in service mode to check that the Class D drive circuit is working. I do need to replace the drive buffers there though, the 3005s, so we're gonna have to do that. And let me just get rid of these diodes here to get it back in service mode. Cool. There we go. And that one there. There we go. So, let's see. Do I have a couple of 3005s spare in my drawer here to drop in to check? Right. What are your... Right, you are 3006. You might work if I've got enough of you. Right, you are scratched off. Okay, so not you. What are you? 3006. So a couple of 3006s there. I'd like to use 3005s if I can, because then we're the same as the other side. Scratched off. Are those two resistors next to the red cap connected? No, they're not. They're not connected on purpose. I explained that in the last stream I did on this. Maybe I'll reconnect them though, just as a sanity check before we power it up again this time. Right, here we go. This looks like something potentially useful. 300. Ah, dude, with a 20, 13 BTR X3. New Fit Fund, man. Thank you very much. I appreciate that, dude. That's really, really kind of you. You've been funding this whole project pretty much, so thank you so much. That's very kind of you. We will order some new parts. Because yeah, unfortunately. Ah, there we go. We got 3005. Right, there's one 3005. Excellent. Yeah, thanks so much, buddy. Really appreciate that. Really kind of you. Really, really, really kind of you. You've funded a lot of this project, to be fair. Scratched off that one. I just need one more 3005, and then we've got the same buffers on both sides. What are you? Are you an 05 or an 06? Can't quite tell. Let's just clean you off a little bit. Run out of isopropyl in this bottle as well. Oh man, Mr. Richmond with a 10 wine fund. Dude, I appreciate that, man. That's really kind of you. I could be sipping some wine while I'm doing this, actually, because this is not a customer repair. There we have a 3005. Excellent. We've got a couple of 3005s. Brilliant stuff. So let's whack those in. Thank you very much to 13 BTR and to Mr. Harry Richmond for your very kind donations, man. I really appreciate that. That's really, really awesome. Definitely helps out when stuff like this happens. Unforeseen problems. Alright, so let's get these drive buffers in, and then we can power it up again on service mode to confirm that the rest of the drive circuit is okay and not hurt by that failure. Ooh. We've got far too much solder on these pads over here, actually. It's kind of making solder bridges, which we don't want. Go on, focus that close. You know you want to. There we go. Okay, there's that one, and let's do the one on the other side. Alright, so I'm just going to put these resistors back. This is a snubber for the output side that I lift because it causes excessive idle current. It loads the MOSFETs, which is not really ideal. But I'm going to put it back just in case it's really needed for these FETs for some reason. It's safer to have it there than to not have it, even if it causes the FETs to heat up at idle unnecessarily. But I'd rather just have it there just for now while we're experimenting, and then we can try it with it removed once everything's happy. Ah, and Florian as well with a 10. My guys, look at you guys, you're sorting me right out. Another 10 from Florian. MOSFETs on me. Dude, thank you very much, man. I really appreciate that. That's fucking awesome. That is wicked. That's definitely more than enough to load this amplifier back up with the full set of FETs. So really appreciate that. That's really, really kind of you guys. Thank you very much. It does make for a great stream. Yeah, it's content, innit? That's what it is. Content. Okay. Right, so we're in service. We're in low voltage service mode. Has your man still got his TVR? Yeah, he's still got the Chimera. He still drives it. It's really good, fun. I've driven it as well, which is it's kind of scary. All right, so we have 3 amps of idle current draw. Why do we have 3 amps of idle current draw? Oh, is it because Ah, it's because my power wire was connected to my remote wire. Okay, let's power that back on again. Right, there we go. Sweet. So, low side drain. Do we have? Right, we have no pulses on there. No pulses on there either. 0.3 amps. Something will be getting hot. What is not happy? Something has failed. What is it? What has failed, or what is dead? What did I just noticed a little capacitor here is a little bit skew with, so let me just sort that out. It's just been knocked off its pad a little bit. There we go. And I think I just need a refill. I need a refill of the old isopropyl alcohol. Where's my big bottle of isopropyl gone? Here it is. The botella. The big bottle of isopropyl. First time in a live! Yo, what's going on? Sergey? Is that how I say your name? Thanks for dropping by, man. Appreciate you coming in to a live. It's a pretty interesting one to join. It's been quite dramatic so far, unfortunately. It's not how I wanted things to go. But there we are. There we go. Right, so in service mode like this, I'm going to remove the fan just to get rid of any current that the fan's going to draw. We got some Class D switching before in service mode, which we should still get. So if we're not, then I think something's happened. Just used isopropyl just to cool down the board a little bit here. Okay, so the maximum temperature thing we've got is 32 degrees at the moment. So if we go power, does anything get hot? 0.3 amps. Okay, yes, we have something 42 degrees over here. So something is getting hot and has failed. Let's have a look with the old isopropyl trick where something will evaporate if it's getting hot. Let me zoom you in on that. So something is getting hot over here. Let's see what evaporates. Okay, not seeing anything immediately kind of evaporate over here. Something was definitely running hotter than the rest. Maybe this 3005 drive buffer actually. Hey, that's actually running hotter than the rest of the stuff. Maybe that one is a bit unhappy here. 11 volts there. 11 volts there. So on this side we've got a bit of the rail voltage is creeping up a little bit because we keep hitting the remote. So let me just dump that rail voltage back down to ground again with my little trusty resistor. Right, there we go. Okay, so if we compare these sides, we've got rail there, which is still at 19. What are you doing at 19 volts, bro? I thought I just dumped you to ground. Bore off. There we go. Right, 9, that's better. Right, stay there. So on this side, we've got... How have we got 18 volts? What? haven't even powered this up yet. How are we getting 18 volts of rail creep in? Right, rectifier goes there. Power supply turns on. We should rise up to 9 and that's it. Right, 8.5. So how are we getting 18 sometimes? 8, 8, 8. Right, that's not moving. Okay, good. Right. So we check this one. 8 volts, and we have 2.3 on the low side. 2.3 on the low side. So we power on. We have 9.9 this side and 10.9 this side. 11.3, so it's rising a little bit. 11.3. Okay. So both sides, low side drains are the same. Do we have any pulses going into the 20957s? Don't think we do. I don't know if we normally do anyway though. Can't remember how these work when they're in service mode. Let's have a look on the internet. What's the input pin to the 20957? 20957S. IRS 20957S. 209. 15-volt diodes wrong way on one channel. No, don't think so. The orientation does flip halfway through. So no, the orientations are correct. I've just checked with my eyes. So pin 3 is the input to this. We're not getting anything. I can't remember if we usually do get input on these. Okay, now that goes up and then down. And that should just go high. Okay. I wonder whether this drive IC, this 20957, I think this might be dead. I think that might be dead. So let's swap that one. Actually, let's just remove that one and let's see if the other side comes to life if we remove this. Let's just use the multimeter real quick to confirm some values. R80. R80. No, that's okay. That's a 103. That's just fine. Let's just confirm some values here. 408. Okay. And this capacitor. That's reading open. That's fine. Diode here. 15 volt Zener. This 15 volt Zener, that's reading okay. And how about this one? 601. That's reading okay, I think, by the looks of it. And then this one here, 585, 564. Okay, I think one of these Zeners might be bad. This one here, 570 one-way round. Yeah, I think that one might be bad. I don't trust these Zeners now on this side, so I'm just going to lift all 3 of them and just measure them out of circuit. This is a pretty hectic failure, considering that it was on a current regulated power supply. All the failure over here has been caused by the energy from the rail caps being dumped through the output section and causing all of this damage here. Big spike. Now we might slightly darken this tantalum capacitor here, but with the heat gun, but is what it is. Right, so let's check these diodes out of circuit. So 600, we shouldn't have anything this way around at all. This should be completely open, which it is. Okay, so that one is all good. This one 600 and completely open. That one is all good. This one 630 something, and okay, no, these are actually all fine. I'm a little bit suspicious of this drive IC though, this 20957, because the way that these work with the input pins for the PWM is that one goes high and one goes low because they're in full bridge, so they need to be working kind of in opposite. And on this one, it kind of tries to go like this one goes low, this one's fine. You can see when you power the amp up, it immediately kind of goes high and then switches to low. Whereas this one tries to go high, but it gets stuck at like 1 volt, which means that, well, it suggests that the voltage is being pulled down internally. So I'm just going to remove this 20957. And might need a new one. But I'm going to remove it, and I'm going to see what the other side of the amp does with that removed. So let's remove that. Now, if this side is okay, we should get some attempts at Class D switching on this side, because it shouldn't be pulling the signal down or anything on the other side. So let's see what we've got. Okay, no, we don't have anything on this side now at all. Man, this is some confu that I'm next to there. Kind of bamboozling still. Why do we still have 0.2 amps of current draw? What's still current drawing with the remote removed? Kind of bamboozling still. Okay, I think the best thing to do is to order some new FETs. Make sure that we've got 4 new drive buffers, some 3005s, because I fitted some 3005s in here, but they were ones from my drawer that I'd used before, so I don't actually know if they work. So that could be the issue here. So just to quit us messing around, let's just go ahead and go to RS Components, and let's order a few more of these output FETs, SUP90-100E. Yeah, fortunately, I don't think they're too expensive. What are they, £3 each? I'm sure, did I pay that much before? Yeah, I must have done. So let's order 4 of these. No, let's order, I got some cool donations, so let's order enough. Let's order another 8 of these, right? So that we can fully load up this amp again if we need to. £37. Okay, there we go. Donations cover that. We've got these right here. This I need some. Wait, what? What is this? The search function sucks on this website. What's going on? I thought I copied that. Copy. Control C. Control V. There we go. See? It does exist on the website. No! Back order! Ah, man. Right, okay, how about the 06s? $25. Oh, maybe this is why I didn't buy any. 150? No thanks. 25. 1 pack of 25 units, £10. Okay. SOT26. Are there any cheaper ones? SOT26. TSOT26? Is that a thing? And also maybe SOT23 6L as well. That'll probably fit. What other ones fit in this case? Okay, let's just roll with that for now. And let's just do number of outputs 2. And let's get rid of that. Let's just have a look at this. What are the specs of this exactly? Technical specifications. So these are number of drivers 1. No. There's no. There is 1 driver. Yeah. Sorry, it's just 1, not 2. It is just 1. Number of outputs 2. Are we just limited to 2? No, because this exists, so that can't be right. What even is this website, bro? Package type, number of outputs. There definitely exists number of outputs 1 because they're right here. SOT26, number of drivers 1. Right. Number of outputs. Maybe that's a different rating. Number of drivers. Here we go. 1 driver. And it's only these. Well, what about the 05s? They're just 1 driver, aren't they? Not 2. Oh, now the 05s are in stock. Bro, this is some bamboozling stuff. Right. Number of drivers. 1. So this website just sucks. Okay. Let's get rid of that. ZXGD 3056 E6TA. There we go. That's what we need. Right, these are only 25 volt supply, but that's fine. That's all we need. Non-inverting, 1 driver, low side. Yes, that's correct. Excellent stuff. That's what we need. Do we need anything else? I think that's it. I'm just going to log in real quick. I normally use DigiKey or Farnell. So I'm in the UK, so DigiKey will charge me a bunch of money on shipping. Farnell also are absolute dickheads when it comes to charging you a service fee if your order is under, I think it's £40 now, which is a lot. So yeah, not into buying from Farnell these days. So that's what we need in order to get this thing finished. And yeah, we'll just test it again with these output FETs. So frustrating, but it is what it is. So let's pop that to one side for now, and seeing as we are on a roll, let's just quickly carry on with the T amp from last stream. This is the T amp, which had a very failed output section, and this is going to be fun. We're going to replace a whole bunch of parts. I've got a whole bunch of parts for the T amp here. So I just grab the board that's needed. Is it this one? Nope. This one right here. Right, here we go. The T amp output section. Right. There's a whole bunch of parts failed on here. And I bought all of the parts to rebuild this thing from the ground up. So, Bigsy me with a 20! Yo, dude, Simon says, can't buy luck. Thanks for the super vids. Man, bro, appreciate that 20. That is extremely kind of you, my friend. I really appreciate you. Hope you're doing well. That's a lot of money to throw to someone on the internet that's just messing around and blowing stuff up. So thank you very much. Appreciate you, bro. Hope you're doing well. These are all the parts for the T amp. Yes, please. We have loads of surface mount resistors because loads of surface mount resistors failed. Let's see if we can have some success this evening. This is quite a lot of parts to replace, so we'll see how far we get, but might as well get cracking with this. Okay, so we have 2 boards here. One of them is very badly failed, one of them is A-OK. We can use these as a reference for each other to fit some dead parts to where they need to go. Let's just open all my packages here. Got some MOSFETs, got some resistors, the stream audio has some weird crackle. Oh really? Is it still there? Got some fuses as well. Oh, Big C. It's not Big C. It's Big Psy. Big Psy me. Big Psy. Not Big C. Big Psy. A lot of random surface mount resistors here in this amp that failed big time. I not long ago gave a T-amp into cash converters. Fair enough. As you do. Cash converters don't give you much money though. What prevented you from just selling it and getting more money? Alright, wicked stuff. So we need to replace a whole bunch of parts over here on this dead board. We need to replace a bunch of these 2R2s. Let's have a look. Yes, sir. We need to replace all these 2R2s because we don't trust any of them. I'm not going to take any chances on this one. We're just going to replace parts where they have failed, even parts that are still reading okay. If there's a chance that they have failed, that they have been weakened, then we're going to change them. So we're going to start off by replacing some 2R2s here. Let's just zoom in for you so you can see nice and clear what we're doing. So 2R2s here. Big boy parts. Get these out of here and replaced. Now, do we need to fit some of our own leaded solder to here? Because this looks like a pretty high thermal mass board, and I suspect they've used lead-free solder, so it's going to take a while to cook up. Oh, no crackling. It was the packets. Why you do me like that, bro? Why you do me like that? Okay, cool. And let's tin the ones on the other side as well. Actually, you know what? I might as well just remove them with the iron while we're here, because like they want to come off. So I might as well just remove them with the iron. Easy peasy. There we go. So you can see what I'm doing. Just flood them with some fresh solder, and then they should just come off like this. Okay, sweet. So they're tinned now by virtue of doing that. Just want to drop some flux on, and then whack on our new ones with the hot air gun. Hopefully it's going to be enough energy on the hot air gun to get these on nice and easy. There's one that I've missed actually underneath here. The sound could get, with PCB weight to make 12 volt power supplies for Hypex Purifier, that would be a game changer. Alright, let's do it. I'll look into this for sure. Sounds great. Do you think that there would actually be a lot of people that would want to use these amps in automotive environment? Do you think there'd definitely be a market for it? Okay. Well, I'm listening. I'm curious. Let's see what we can do. Damn, these resistors are a lot thicker than the one than the ones that came off the board. These are some chunky boys. Wow, yeah, that's a thick boy. Okay. Yeah, so the model car for Boom or Bust Season 2, I need to go and collect it. I just haven't managed to get there. It's like going to be a, what is it? It's going to be like an 8-hour round trip. So, yeah, I need some time. And I also would like to have another reason to go in that direction, to go in that area of the country to make the trip feel kind of worth it. It's a long way to go. I'm extremely busy with all sorts of stuff, so... do you know many of the resistor values from the colors without checking? Not a couple of them. I don't know loads of them off the top of my head. I know lots of common ones like 10 ohms, 47, 22, 1K. What else do I know off the top of my head? $470. But yeah, I don't know all of them. I don't know the greens and the oranges that well, but yeah, I always just look it up to be sure. I'd rather look it up and double check than order the wrong parts. So just realized you couldn't see what I was doing then, but that's fine, you can now. It's all good. What T-amp model is that? This is the E1500. It's the E1500. Uh, 4 hours. Where are you going? North Scotland? No, I'm going basically the complete opposite end of the country. I'm going from Durham, UK, to Fleetwood, UK. I think it's like it'll be 3.5 hours each way, but then obviously there's like going to be a bit of time collecting the thing and paying, and then like stopping on the way. So yeah, it's going to be probably like at least 8 hours round trip, maybe a little bit more depending on stuff. So super powerful, clean and efficient. You could slap it in a chassis and boom, you have your own amp, the Sam 5000. You see, that's tempting, but I wouldn't want to do that because then it's not my own amp really, is it? But maybe it would be a good first initial like thing to put my name on. I wouldn't claim it to be my own. I'd be like, hey look, this is just generic amplifier section, but I'm giving it a power supply. I don't know. So, alright, cool, we have all of our new 2R2s. Right, what's the next resistors set that we need to change? We need some of these ones in the middle. So these ones in the middle, they are going to be, let's have a look, compare them to the other side. 1201. 1201. Okay, a little bit of flux. And 1201. Not that one, but that one. I don't actually know if this needs these resistors here. Ooh, I don't know. I can't remember. Because obviously one of these is channel 1, one of them is channel 2. I don't know for sure whether this one has these resistors here or not. Because they're not present on the board, so I don't know if I removed them ages ago because they were burnt. I don't know. But we're going to put them in anyway and I guess see what happens. Unless anyone's got a T-Amp TE1500 laying around, they can just pull the top off and have a look to see whether both channels have these resistors fitted here. To be fair, actually looking at it, the capacitor here has a little bit of melting. So I imagine that I actually have removed these resistors because my hot air gun or my soldering iron has definitely been in here. So yeah. Okay, I would say that they are present then, because yeah, otherwise that cap wouldn't be a little bit melted. Detective work, you see. Oh man, don't make me cook the side. Don't make me cook that capacitor, please. Have you got a lot of thermal mass on this part of the board? I'm just going to use my main iron. Screw this. Yeah, I was holding that on for a good like few seconds and it wasn't even starting to melt. So I'm just going to use the main iron on these pads just to save cooking that capacitor. I suspect one of these is a ground trace or something. There we go. There we go. Whey! There we go. Now let's just get the other one on the other side. There we go. That'll do. You're soldered in, aren't you? That's all you care about. There we go. Very nice. Muy bien. Right, next set of resistors, we have these ones right here. This cooked 3301. So let's just get that cooked one off the board. Death Dragon, thanks for jumping on, man. Appreciate you being here. Catch you later. Okay, and we have some, what is this, 3301. That's one of these ones. Straight up says, designing an efficient power supply is a lot deeper rabbit hole than people think. Push-pull has limits. Car audio needs more efficient designs, not regurgitated old topologies. I agree with you, but if I was to go down that route, it just would never happen. So I can either take some what's it called? Take some inspiration from some well-designed pre-existing push-pull power supplies like Alpine. So I could use a H bridge. I could use a high side, low side H bridge, half bridge power supply, which I know that Alpine have used in quite a lot of their amplifiers, which is supposed to be better, which would be something different, wouldn't it, than just your regular push-pull that everything else uses. So it'd be something a bit different and a bit better. Hey. Okay, 3301 replaced. Now we've got some big ones here. We've got some big beefy ones right here which are cooked, as you can see. We've got a 5100 and a 3900, so they've got to get out of here. Now unfortunately I couldn't find a 3900 resistor, which is a 390. I couldn't find a 390 ohm resistor in surface mount size that was quite the same, that was the same size as this one. Like, 390s were either a lot smaller or a lot bigger. Well, I say a lot smaller. So I've gone for one that's a little bit smaller, but was very thick and that had a decent power rating. So this is the 390 that I've chosen. Let's just see the size. So yeah, it's a fair bit smaller. You know what I might do? I might just series parallel them. See that 390? I don't like. That's quite a lot smaller, isn't it? It is a thick one, so it does have a decent power rating, but there's enough space there that I could probably just series parallel them to give us a 390 again. Maybe I'll do that. I'd rather over-spec it than under-spec it, you know? There is enough space there for me to drop 4 in series parallel, so I think we'll just do that. Okay, and then the other one that I need is oh no, wait, did they send me the wrong... Oh no, they've sent me the wrong resistor! 151, 150, that's not what I need, is it? I don't think. Bro! I need 510. They've sent me the wrong freaking resistors. Fuck. Oh, well I guess we ain't powering this up tonight either. What a nightmare. Oh man. Tonight has not really gone to plan. Actually, I don't think I can series parallel these because we've got these got this board trace in the middle here that this is going to short against, isn't it? Okay, let's just roll with one for now and let's just see how hot it gets in circuit. I did like the power spec on this resistor is more than it looks, so worst case I can always put a through hole resistor in place, but I just wanted to try and keep it looking neat if I could. So right, let's put these 390s in a drawer. And let's put the rest of these away. 390. This is 3301. $150s. Well, I do have the fuses. Hopefully they're right. 12 amp fuses. Which are these ones? Which are these ones here. So I should just be able to whack those in. Check they sent me the right fuses. Yeah, 12 amp. There we go. Very nice. I guess I could steal the 510 from this side just to whack it in here to power it up and confirm that it works. I did also order some emitter resistors. Where are they? They've not turned up. The MOSFETs are here though for the Class H switching, so that's good. Yeah, bit of an annoying stream with the parts failing on the Bassface, missing or incorrect parts here. Just a bit annoying, really. It's turning out to be a bit of an annoying one. Yes, this is class H, so it's class AB, but the rail voltage switches gradually higher voltage as the sine wave gets higher in amplitude, which is what class H is, I believe. Whoa. So these are some replacement MOSFETs for the class H switch. They're not the same as the originals, I don't think, but they'll do the job. I don't know what the T stands for, to be fair. 140 NF75. Yeah, that's the ones. That'll do. Okay, MOSFET. Little bag of screws. Electrical tape. MOSFET bag. Little bag of screws. Alright. Solder these in place. Alright, wicked stuff. So I think that is as far as it will let me get tonight with this one, without the resistor that we need. I also need to try and find all the screws for this as well. There's some screws that are missing. They'll be in a bag somewhere. But it's been a pretty long stream, 3 hours and 9 minutes so far, and we've done a lot, but also not got a lot done. So just happens like that sometimes. These are some of the inductors that we're going to be fitting to the Bassface amp. Not these exact ones because these are too burnt, but this size of inductor to the Bassface amp to modify it once the output section is actually happy. So yeah, thanks for sticking with me, guys. It's been a nice old stream. Where should I put these? Should I put these in other 100? Yeah, we're going to put this up here. Been a nice old stream, been a good fun one with you guys. I'd love to have a chat with you, Sam, but I don't have Facebook. How else can I contact you? I don't have Facebook. Maybe WhatsApp, but I don't want to give my WhatsApp details here because I don't want to have that out on the internet, because I generally just use WhatsApp for like personal contact and stuff. Do you have WhatsApp? But if you have WhatsApp, then message me somehow, somewhere, and I'll give you my WhatsApp. Yeah, I've got WhatsApp, and I know some of your number. Yeah, cool. Yeah, just grab my number, add me on WhatsApp if you know my number, and then we can just chat on there. But yeah, it's gonna be. I'm gonna order these parts for the Bassface, and then probably next week we'll jump on another stream where we try and figure out what was going on with the Bassface and why it decided to kill the vets with full rail, but was happy on service mode. Very strange one, that. And figure out why we're missing emitter resistors from my order from RS Components, and why they sent me 150s rather than 510s. But yeah, thanks for sticking with me then, guys. I will see you in the next stream. Take it easy. Have a great weekend. Bye bye bye.